Here are solutions to all of the collected warm-up problems. So first, what is the problem with this code? Well, let's read line by line. So here, this seems to be creating a two-dimensional int array that has 5 rows and 3 columns. And then we're running a fill grid method where we give it that array as input. So the array gets copied here into grid. And now we're looping over rows and columns, and we're assigning values. So there's 2 things that I see wrong here. First, the fill grid command should work no matter what size the input array is. But here I have the numbers 5 and 3 hard-coded in there. So if I was going to make an array of a different size, the command wouldn't work anymore because it would only loop over 5 rows and 3 columns. So that's the first problem. The second problem is once we're inside this method, there is no variable called r anymore. R is the name of the variable in main. But when we ran the command, we took r and we assigned it to the grid variable. So inside this method, grid is the new name for r. So the solution here would be you have to ask the array how many rows it has. And you do that using the name of the array and then .length. And then I have to ask it how many columns it has. So we can do the array name and then bracket 0 and then .length. And then the last thing is we have to be using the name grid all the time inside the command instead of array because there is no such thing as the array variable inside the command. Okay, question 2. The lightning bolt shows you where grid row call is. How would you put the number 8 into the red square and the number -3 into the blue square? So remember, because 0, 0 is in the upper left-hand corner, as you move columns to the right, you are adding to the column. So this would be like, you can imagine column 0, column 1, column 2, like that. So even though we don't know the exact number for which column we're talking about, I know that one column to the right is going to be call +1. You can see that the red square is in the same row as the lightning bolt, so we don't need to change the row. So we can just say grid row, that's the same, and then call +1 is one column to the right, and then we want to put the number 8 inside like that. How would we put it into the blue square? Very similar, so we'll do grid, only this time you can see that the row of the blue square is above the lightning bolt, so that would be row -1, and then it's to the left of the lightning bolt, so it would again be column -1, and we're putting -3 in there. Why does going up mean that you subtract 1 from the row? Remember, if the top row is row 0, that means as you go down the rows, you are increasing their number. So this, you could imagine row 0, row 1, row 2, and so on. So if you want to go up a row, that would be like subtracting 1 from the row number. What would you type to make a new two-dimensional array that holds strings whose width is 10 and whose height is 2? And this picture has very little to do with this question. I just wanted to have a picture of an array there for you to think about, and also to remember that these horizontal things are the rows and these vertical things are the columns. So remember, you always start with the data type, and the data type is int bracket bracket, so 2 sets of square brackets. You can name the actual array whatever you want, so I'm going to call mine Bob, and then you type new int, and then you have to tell it the height, which is the number of rows. So here we want a height of 2, and then you tell it the width, which is the number of columns, and so that would be 10. Notice that if you have a height of 2, the actual location numbers are going to start at 0, so it would be 0 and 1. But when you first create the array, what you put in the bracket is literally equal to the total number of rows you want or the total number of columns you want. What does this display? So mygrid 0, 0, you can see is the number 21. Mygrid 0, 1, remember it's a row first and a column second. So row 0 is this one. Column 1 is this one. So mygrid 0, 1 would be the number 6. 21 plus 6 is 27. In this problem, we create two variables, a and b, and we use a and b to access locations in the grid. So you have to understand what are a and b. MyGrid.length, remember, tells you the total number of rows. So MyGrid.length minus 1 is the location number of the last row, because if I have 3 total rows, 3 minus 1 gives you 2, the location of the last row. Same thing for columns. So MyGrid0.length tells you the total number of columns, so that would be 5. If I subtract 1, that gives you 4, the location of the last column. So if I want to know where is MyGrid AB, A is the location of the last row, B is the location of the last column. So the answer must be 34, because it's the last row here and the last column here. So now we're going to do 34 plus something else. Here I see that we're in row 0, so that's going to be here. And we're in B minus 1, so that's the last column, but then I'm going to subtract 1 from the column to take me here. So that would be 62. So 62 and 34 is 96. In this problem, we have a pattern where the row variable starts at 0, goes up by 1 every time as long as it's smaller than 3. So we're going to be visiting row 0 first, then row 1, then row 2. So you can see the row variable being used in the location where we describe rows. We're always in column 1, so that's this column. So as we're looping, we're going to visit the number 6, then the number 56, then the number 35. Except you notice that there is no print line statement inside our loop, so we're not displaying each of those numbers. Instead, we're taking each of those numbers and we're adding it to a sum variable, and we save the result back inside sum. So what that means is that as we repeat, we're adding each new number into the sum so far. So the result at the end is going to be what you get when you add 6 to 56 to 35, which is 97. You see here the regular pattern for looping through all rows and columns. So we have an array with 3 rows and 5 columns, and we're looping through all the rows and all the columns. If we were going to assign values to the array, what value would we assign here? Well, clearly this is row 2, column 3. So at the moment that we're at that particular row and column, we'd have row 2 plus 2 times the column number, which is 3. So that would be 2 plus 6 is 8. So the green number should be 8. This was a warm-up we did at the very beginning. So here we have an array. What will each line display? So array 0, 0 is the number 3. And we add 2 on the outside, so that means we're adding 2 to the number 3, which is 5. Here, the plus 2 is inside the first bracket, which means that it's going to be used as a row number. So 0 plus 2 is 2, and so we're using 2 as the row number in column 0, so that would be 44. So the answers are 5 and 44. Here, we're looping I from 0 up to 2, including 2, and we're using that as a row number, but we're in column 0. So here's column 0. So this is going to display 3, 9, 44. What will it display if it's the same loop, but I is being used in the column location? In that case, we're in row 0 here, and so it would display 3, 7, 2. The reason it wouldn't display 0 is because we never actually visit location number 3, because I only goes up as long as it's smaller than 3. So when it's equal to 3, we would exit the loop, and we wouldn't actually display the value where I equals 3. So the answers here would be 3, 9, 44, because we're going down column 0, and then 3, 7, 2, because we're going across row 0. Here's another one. If I was going to create the array shown here, it's got 3 rows and 4 columns. So this number would be 3, and this number would be 4. If A equals 2 and B equals 1, then I would take 2 times b, which is 2, and I would put it at row 2, column 1, which is here. Then I take the number at that same location, at row 2, column 1. So on the right-hand side of the equal, that's equal to 2. And I'm going to take that number 2, and I'm going to assign it to row 0, column 1, which is right here. Now I'm going to take a plus b, so that's 3, and I'm going to assign 3 to the upper left-hand corner, like this. Then I'm going to take the number 3, and I'm going to assign it to row 0, column 3, which is right here. Then I'm going to take 5 and assign it to a location that we have to think about. So let's see, I've got a is 2 and b is 1. So 2 minus 1 is 1. So I know I'm in row 1 here. Column is going to be 2 plus 1, so that's 3. So I'll be in the third column, which is here. So row 1, column 3 is right there, and that's where 5 goes. And then the last one is an error because there is no row number 3. And specifically, that would be an array index out of bounds error. Okay, how would we fill in the blanks so that we display 3, 5, 8, 7? Well, it looks like the column number is always the same. The column number is always 1. The row number is changing. So it looks like I is the name of our loop variable. So I'll make this I. And we're starting at row 1 because the top row is row 0. And so this row is row 1. And we're going to go from row 1, 2, 3, 4. But I wouldn't actually want to put 4 here because this is saying I is smaller than 4. But we actually want to go to row 4. So we'll say I is smaller than row 5. And that will be sure that we're going to visit that last row. Let's do another one. Let's say that we are going to, wait, this is the same one. Okay, this is a different one. So we're here, the row number is always the same. We're at row 0, 1, 2, 3, 4, 5, 6. We're at row 6. So because that never changes, I can just put 6 here. Then columns are what's changing. So I'm going to put I there. And we're starting at column 1, it looks like, because this is column 0. So here's column 1. And we're going to go column 1, 2, 3, 4. But for the same reason, I don't want to put 4 here because that would mean that I is smaller than 4, which means we'd never visit when I equals 4. We'd stop here at I equals 3. So instead, I'm going to put one more, 5, because as long as I is less than 5, that means that I will actually visit this location when I equals 4. Let's see, 0, 1, 2, 3, 4. Yes. What about this one? Well, here I'm noticing that the row and the column are changing, but they're also the same all the time. So here, this is row 1, column 1. This is row 2, column 2. This is row 3, column 3. So, oops, I don't know why I just wrote 3 there. So I is the variable that we have in the loop that's changing. So we'd want to start I at 1 because we want to start at row 1, column 1. Then we'd have it keep increasing so that it's 2, 2, and then 3, 3, and then 4, 4. And then we want to stop when we get to 5, 5, or we want to stop as long as it's smaller than 5, 5. Let's fill in the blanks so that we create this grid and fill the inside with numbers. So here we have the data type, int bracket bracket. Here, let's see, how many rows do we have? 1, 2, 3, 4, 5, 6, 7 rows. How many columns do we have? 1, 2, 3, 4, 5 columns. Okay, so here's the double loop. So we want to be looping through just the middle ones. So I don't want to start the row at 0 because I don't want to put any random numbers into row 0. So I'm going to start at 1 because that's the first row where I actually want to put stuff. And then I'm going to keep going as long as row is less than this last row. So let's count up. Here's row 1, row 2, row 3, row 4, row 5. So I want to be smaller than row 6 because I want to be smaller than the last row. Same thing for columns. So for columns, I want to start at column 1. We want to visit 1 and 2 and 3. And so then we'll stop before we get to column 4. So columns have to be smaller than 4. And finally, we'll say grid RC is where we're actually putting the random numbers. Okay, let's look for the bug in this code. This code is supposed to return true if the input grid contains a value, otherwise return false. So it looks like we're looping over all the rows and looping over all the columns, and that looks fine. So we're visiting every single location. And then we ask the question, is the number at that location equal to the value that we're looking for? And if the answer is yes, we return true. And that part also seems good. The problem is with this else statement. Remember that this if statement runs for every single number. And so let's pretend we're looking for the number 5. The number 5 is in the grid, so we would want this command to return true eventually. But we're starting by looking at row 0, column 0, which is up here. So if you imagine the very first time we run the if statement, R is 0, C is 0, we say, what's at 0, 0? And the answer is, it's this number up here, 0. And we say, is that number 0 the one that we're looking for? Is it equal to 5? And the answer is no. So we go to the else statement, and then we immediately exit by returning false. So what it means if we return false is we're saying, no, the grid does not contain that value. But it's too soon to answer the question because we've only looked at this one number. So if we don't see the number we're looking for in any particular spot, we can't say that we haven't found it yet. We can't say that the array doesn't have it. All we can say is that we haven't found it yet. And what that means is that we should just keep looping. So a solution to this problem would be don't have an else statement because we can't return yet. We don't know if it's going to appear later on as we continue to loop. We can only decide that it doesn't have the number at the very, very end because after all the loops, that's where if we haven't found it, we know that it's not going to happen because we've checked all the locations. So you could return false out here at the very end. If you're worried that it's going to return true and then keep looping and then eventually return false at the end, don't worry. As soon as you hit a return statement, it exits your entire command immediately. So if this if statement is ever true, then you immediately exit with the answer true, and you would never even get down here. Here's a method that's supposed to take an array as an input and then add together the upper left-hand corner and the lower right-hand corner, and then give back that answer. So if it's supposed to take a grid as an input, I need to say int bracket bracket is the data type for a two-dimensional int array. Let's get the number in the upper left-hand corner. That's easy enough. So upper left is going to be array 0, 0. Lower right is a little bit trickier. I like to split this into several variables. So let's name last row array.length. The only reason I'm doing this is because last row is easier to look at and think about than array.length. So last column equals array 0.length. And now if I want to get the number in the lower right, the number in the lower right is the array at the last row and the last column. So if you wanted to, you could have array.length appear directly inside the brackets, but that's going to lead to a fairly long expression that I think is harder to look at and think about. So we have the upper left-hand corner, we have the lower right-hand corner. So at the very end, you want to have a return statement that returns upper left plus lower right. How would you write a command that loops over everything and counts how many of a particular input value there is? So you've done this problem once before, I believe. Let's make a counter that starts at 0, and then we'll have the regular pattern where you'll loop over all the rows, grid.length, and then we'll loop over all the columns. So int c equals 0, c is less than grid 0.length. And then what do we want to do? We want to get out whatever value is there. So the value in the grid is going to be grid location R, row R, column C. And then counter equals, oh, sorry, I forgot what we were doing. I thought we were adding together all the things. So I want an actual if statement. Oh, we can still get the value out. And then I can say if the value in the grid is equal to this val up here, the input val, because that's the number that I'm trying to count how many there are. So if the value in the grid is the value I'm looking for, then I'll add 1 to the counter. And then I want to return the counter at the very, very end. So here at the end, I can say return counter. And that's going to be how many I saw. Remove negatives. So I want to replace all negative numbers in the grid with 0. Okay, there I've changed some of the numbers so that there actually are negatives. So what I want to do is loop over every location. At every single location, look at the number and say, is that number a negative number? And if the answer is yes, then I'd want to replace it with a 0. So that's what we're going to do. Let's start with the pattern where we loop over all the things. So row is 0, row is less than grid.length. I feel like this is so familiar. I feel like we just did this. For int column equals 0, column is less than grid 0.length, and then column plus plus. Okay, so now I'm looping over all the places. Let's ask the question, is the number there a negative number? So is grid row column smaller than 0? Because that's what it means to be a negative number. And if it is, then what I want to do is I want to replace it. So grid RC is going to get replaced with 0. And that's it. Oh. Why are we returning int? Count how many of us are... Oh, I didn't change my slides. Okay, well, so by the time this gets to you, I will have changed this. Okay, there are 3 bugs with this isInBounds method. So what are they? So the first bug, let's look at it. So I want to see, it's asking, is my row larger than or equal to 0? And also, is my row smaller than array.length? But it's also saying, is it equal to? And you see that inside the if statement, we're going to return true, which would mean, yes, it's in bounds. So one bug is, if the row is equal to array.length, it's actually out of bounds. It's 1 too large in the row. And it helps to have a picture in your head with the rows. So here, let's imagine, so ignore the rest of this, just look at the array. So here, my grid.length is 3 because there are 3 rows. But if I tried to access row number 3, that's out of bounds here. And so I wouldn't want to return true to say it was in bounds. If my row number is equal to the number of rows, then that means I'm out of bounds. So I'd want to return false. So let's go back over here. So it's only in bounds if it's smaller than the number of rows. If my row number is smaller than the total number of rows. Same thing for columns here. So it's okay for column to be equal to 0, then I'm still in bounds. But my column number can't be equal to the total number of columns, because that would also be out of bounds for the same reason. Okay, so then the other problem is with this else statement. This else statement only attaches to column here. So let's pretend that my row number was out of bounds. If my row number was out of bounds, then I wouldn't even do any of the code inside here. I'd skip directly to here because my row was out of bounds. And now the code is down here, but it doesn't know what it should be returning because I didn't have a return statement. So out here, I would want to say return false. And actually, it would be even cleaner just to remove this else entirely. So that way we just have 2 conditions. We're going to return true if all of this stuff is true. If the row is in the bounds and also the column is in the bounds. That's when we'd return true to say, yes, it's in bounds. If we don't return true, then at the very end we'll return false. So that's a clean answer to the problem. The bug for this problem is very similar. So here it looks like we're making a new grid whose height is height and whose width is width, and that makes sense. Then we're looping over all the rows and we're looping over all the columns. It's a little bit weird to name your loop variable I if you're looping over rows, but we see that it's being used in the location where you talk about rows. So that's okay. That's not going to lead to an error in what the method's supposed to do. Here's the problem. The problem is where the return statement happens. You'll notice that the return statement happens inside this row loop. So what's going to happen is I is going to be equal to 0, which is like the top row. We're going to loop over all the columns in the top row, and we're going to assign random values to all the spaces in the top row. And then we're going to exit, because that's what return does. Return exits. Oh, I see another bug. But it's too soon to exit because we've only visited the top row. We haven't visited the other rows yet. So we need this return statement to be outside all of the loops. We don't want to return to the very end. The other bug is NO is a two-dimensional int array, but here I see my command thinks that it's just returning a single int. So this should be int bracket bracket. So a student is complaining that sometimes their code goes out of bounds, and it looks like they're trying to put the number 1 into the location row -1 and call. So let's think. So we want to check if the column is in bounds. So column has to be larger than or equal to 0, and column has to be smaller than the total number of columns. So that makes sense. It would be wrong to do row and row here. And the reason why is, because this would be checking to see if the number row was inside the grid, but we're not actually putting a number into row. We're actually putting a number into row -1. So let's pretend that row was equal to 0, for example. If row equals 0, then this is going to return true because 0 is an okay place to look in the grid. It's the top row. But the problem is I don't actually put the number 1 inside of row 0. I actually put it inside of row -1, which would, and if you evaluate this, that would be 0 -1. So I'd actually be putting this inside the location -1, and that's outside the grid. So one solution, so my favorite solution is, let's take this number right here, row -1, because that's the number where we're actually looking in the grid. And I want to make sure that number is greater than or equal to 0. And that number is smaller than the edge of the grid. Because if you think about this as being a single number, and that's the number that we're going to be assigning, then it makes sense that you would want to run that same test on the location that you're actually saving into. Equivalent to this, if you want to kind of think about it differently, you could say that if I'm going to be subtracting 1 from the row, then that means my row has to be bigger than or equal to 1 in order for it to be safe. Because if row equals 1, then it's okay for me to subtract 1 because then it's going to be 0 and that's still in bounds. And then same thing over here. If I add 1 to both sides, you can think about this sort of like algebra. Like I had a -1 here, nothing on this side. So if I add 1 to both sides, it becomes this. So here, if I'm going to subtract 1 from the row, it's actually okay for the row to be equal to grid.length because I'm going to subtract 1 from it. So what that means is that row no longer has to be smaller than grid.length. It only has to be smaller than grid.length plus 1. That first way was my favorite way of thinking about it. I think that this second way is more confusing, but that might just be me. So you can use whichever way makes the most sense to you. Okay, that's it. Good luck, everybody.